Welcome to DC Digital Learning Session. Now I have to discuss separation of symbols. I am Dr. Shobhan Kumar DM, working as assistant professor in the Department of Mathematics, Maharani Science College for Women, Bangalore. Here, suppose the function f of x is represented by ux. Here, any function, this is f of x is represented by ux, then e of f of x is equal to f of x plus h. Already we know that definition of shift operator. Here, e f of x equal to f of x plus h is denoted by this. E f of x equal to f of x plus h is denoted by ux plus nh, and f of 0, f of 1, f of 2, and so on, f of m are represented by u0, u1, u2, and so on, um. Therefore, ux plus nh is equal to e raised to n ux. It can be denoted in the form of shifting operator. It should be written in this form, e raised to n ux, e raised to n ux. That is equal to, we know the relation between e and delta. E is equal to 1 plus delta, 1 plus delta over to the power n ux. Now expanding 1 plus delta over to the power n by using binomial expansion, we get 1 plus nc1 delta plus nc2 delta square plus and so on. And so on, 1 to the power n is 1 itself last time. Okay, into ux. Now simplifying, 1 into ux, nc1, delta operating on ux, delta ux, plus nc2, delta 2 ux, plus and so on. Here, the operand is separated from operator. This type of operation is called separation of symbols. Is called separation of symbol. Here, operand is separated from operator. This is nothing but separation of symbols. Now we have to discuss some examples, few examples. By using method of separation of symbols, prove u0 minus u1 plus u2 minus and so on is equal to 1 by 2 u0 minus 1 by 4 delta u0 plus 1 by 8 delta square u0 minus and so on. Here LHS is u0 minus u1 plus u2 minus u3 and so on. Now I have to prove 1 by 2 u0 minus 1 by 4 delta u0 plus 1 by 8 delta 2 u0 minus and so on. Let us consider left hand side. Here u0 minus u1 plus u2 minus and so on. We know that u0 you can write down as it is. u1 is, it can be written as e u0, and u2 can be written as e square u0. Therefore u0 minus e u0 plus e square u0. Here by using this definition. Here u0 take it outside. Remaining 1 minus e plus e square minus and so on u0. Now, 1 minus e plus e square minus e cube and so on, this is nothing but 1 plus e whole to the power minus 1. Because by binomial expansion, 1 plus x whole to the power minus 1 can be written as 1 minus x plus x square minus x cube plus x to the power 4 and so on. Therefore, here 1 plus e whole to the power minus 1 is nothing but 1 minus e plus e square minus e cube plus minus and so on. Therefore, here it can be written in this form 1 plus e whole to the power minus 1 into u0. Now, by relation between e and delta, e can be written as 1 plus delta. 1 plus delta. Here instead of e, we write 1 plus delta. 1 plus 1 is 2. 2 plus delta whole to the power minus 1 into u0. Into u0. And again, here 2 take it outside. 2 raised to minus 1 can be written as 1 by 2. Here within the bracket remaining 1 plus delta by 2 whole to the power minus 1 u0. And again applying binomial theorem. 1 plus x whole to the power minus 1 is 1 minus x plus x square minus x cube plus x to the power 4 and so on. Here instead of x, delta by 2. Therefore, 1 by 2 into 1 minus delta by 2 plus delta square by 2 square minus delta cube by 2 cube plus minus and so on into u naught. Now this is an operator operating on u naught. 1 by 2 1 into u naught plus 1 by 2 as it is delta u naught plus del square u naught by 2 square minus del cube u naught by 2 cube plus and so on. This is our required result. This is our required result. Okay, this is the required result. Therefore, here it can also written as okay, this is the required result. And another example, prove that u naught plus u1 plus u2 plus and so on un is equal to n plus 1 c1 u naught plus n plus 1 c2 delta u naught plus n plus 1 c3 delta 2 u naught plus and so on delta n u naught. Now consider left hand side u naught plus u1 plus u2 plus un. Now using a shifting operator definition, E f of x equal to f of x plus 1. According to that, u naught is u naught, u1 is here u1 is nothing but ux plus 1h. Therefore, it can be written as E u naught plus u2 can be written as E square u naught plus En un can be written as En u naught. Here plus sign is there. Okay, here plus sign is there. Here plus is there. Sorry. Here plus is there. Sorry. Here plus is there. This is the last term. Okay. Right. And here also I put plus. Here plus is there. Plus e raised to n. Plus e power n. Plus e power n. Okay. Now, and again 1 plus x square plus and so on x square here in this form. Now it can be written as here instead of x here e. Now 1 plus e square plus and so on e raised to un. Now it can be written as this is a geometric series. Now summation here 1 plus r square plus and so on r to the power n. The sum of the geometric series is r to the power n plus 1 minus 1 divided by r minus 1. Using that formula, here we get e raised to n plus 1 minus 1 divided by e minus 1 into u naught. And again, e is nothing but 1 plus delta. Relation between e and delta, 1 plus delta over to the power n plus 1 minus 1 divided by e minus 1 is a delta. E minus 1 is delta, e minus 1. E can be written as 1 plus delta, 1 get cancelled, remaining delta. We are using this relation. Now delta take it outside, remaining 1 plus delta all to the power n plus 1. Now expand this by using binomial expansion. Here 1 plus n plus 1 c1 delta plus n plus 1 c2 delta square plus n plus 1 c3 delta cube plus and so on. And so on. Okay, u naught. Now 1 by delta. Here n plus 1 c1. Now it becomes here 1 here integration of this 1 by delta on 1 plus n plus 1 c1 delta plus n plus 1 c2 delta square plus n plus 1 c3 delta cube plus and so on delta raised to n plus 1 minus 1. Here 1 get cancelled. 1 get cancelled. Here operating on this. Now it can be written as 1 plus n plus 1 c1 n plus 1 c1 delta u naught plus n plus 1 c2 delta 2 u naught plus n plus 1 c3 delta 3 u naught plus and so on and so on. Here 1 delta get cancelled now, 1 by delta 1 delta, here delta n u naught. This is required right hand side. This is the right hand side. Okay. And another one, do that ux equal to ux minus 1 plus delta ux minus 2 plus delta square ux minus 3 plus and so on plus delta n ux minus n. Now consider left hand side, or here you have to prove right hand side to left hand side. Okay, or here it can be written in this form, just rearranging. Here ux minus 1, here use take it on side, here ux minus delta n ux minus n is equal to ux here both sides. Here it can be written as ux minus delta n ux minus 1 is equal to ux. Here instead of delta n ux minus 1, it can be written as delta n keep as it is, and ux minus n can be written as e raised to minus n ux. That is equal to, now ux take it outside, remaining 1 minus delta n e power minus n. Now it can be written as 1 minus delta n e raised to minus n can be written as 1 divided by e raised to n into ux. Now take the LCM and en, e raised to n minus delta raised to n divided by en into ux. Here 1 by e raised to n, take it outside, remaining e raised to n minus delta raised to n ux, where I is the identity operator. This is an identity. Therefore, here, this is an identity operator, 1 divided by e raised to n into e raised to n minus delta raised to n. This is identity operator. I is equal to e minus delta, because 1 plus delta is equal to e is equal to 1 plus delta implies 1 is equal to e minus delta. Therefore, instead of 1, we can write e minus delta operating on ux. Here 1 divided by e raised to n, and simplify it. Here after simplification, e raised to n minus 1 plus delta t raised to n minus 2 plus del square e raised to n minus 3 plus and so on plus delta raised to n minus 1 into ux. That is equal to here e raised to n minus 1 by e raised to n. E raised to n get cancelled, remaining e raised to minus 1, and here also e raised to n get cancelled, plus delta e raised to minus 2 plus del square e raised to minus 3 plus and so on delta raised to n minus 1 e raised to n minus n into ux. Therefore, e raised to minus 1 can be written as ux minus 1 plus delta ux minus 2 plus del square ux minus 3 plus and so on plus delta raised to n minus 1 ux minus 1. Thus ux is equal to ux minus 1 plus delta ux minus 2 plus delta square ux minus 3 plus and so on delta ux minus n. This is the required result. Similarly, prove this one to yourself. This is very simple. And exercise, try to solve these two problems by using separation of symbols and go through these references. Okay, thank you.